Hello, hello. Okay, so let's start. Okay, so today we are going to solve this um, tree boundary traversal. Okay, so let's see what this question have. Uh, in a given tree, find its boundary traversal. The traversal should be in the following order: left boundary, and the path from the right to the leftmost right, the leftmost. Okay. And then all these nodes in left to right order and reverse right intersection. Okay. Okay, let's mm, so let's start. So according to question, like if we have a tree two, three, four, five, 6, and let's take one more. 6, 7, 8. Okay, so according to like question, first only go towards left and get all its nodes. So 1, and then go towards 2, and then get 3, and after this get all the leaf nodes from left to right. So this will become, we will come here and we will get 7, and then 8, and then afterwards get all the rightmost node. So this will be our answer, like because we go to 1 and then 2 and then 3 and then 7, 8, 5 and 4. This will be our answer. So how we should perform this? Like we can break our problem in 3 parts. Like in first part, we will find all the leftmost from root to leftmost nodes. Okay, this is a first break, and after that, second in which we will get all the leaf nodes, and the third break will be to get the rightmost one. So I think we have to solve in this way. So let's code it here. Let's see this what we I think is what. First we have to code for that. So for length def, let's name it left with the root and make a global variable with the name of um, left. Okay, left underscore nodes. Okay, and after this in left we have to root, just return null. And if there is row, then just get that node and in the this left node list. Mm, nodes chart then the root value then root data. And after doing this, because we are only going in left, and we have to find the leftmost element. So then it will be like leftmost point, and then we just traverse to left. So left, root, not left. I think this will complete our left side traversal, and for right side traversal we will do the same, but in left. Mm, then for right side. And for leaf nodes, we'll make again a new global variable. Oops. Then make a function. If it's root, then just return, and after that go take that like if check if it is a left leaf node or not. If not, uh, let's make it like this. If root dot length double equals to root dot right, and then double equals to null. If this condition follows, then just add this guy in our leaf nodes list. Mm. And if this condition follows, then just go in left and right both direction. more than like union root dot left and leave root dot right. Okay, so after doing all this, we have to just merge these list. So to merge, we will pop the last element from the leaf node because that will be in our leaf nodes. So pop the last guy also. Let's sorry, not leaf. Okay. So what we have to return is left nodes. Okay. Here we will return all the left nodes, and in leaf node we will remove the first from that. So we will traverse from first will be 0 index, so it will be 1 2 1 2 my okay, let's 1. Okay, and after that for right nodes, because 1 is already in leaf node, the first one root node is already in leaf node, so we have to remove that also. So we have to traverse from the, and we also have to remove the right nodes. Okay, here we will take -1, first and last both remove, and in right nodes we have to traverse in whole with -1, and we don't have to take the 0 element because that will be, so we will put it 1 here. No, 1 no, it's 0 because indexing. Okay, so column 0. Okay, so let's go there and check if this works or not. So for our left, we have to make a left, and it's put its global variable that left nodes, left nodes list, and left in left we have to put a node, and if not node, then just return, and if there is node, then just take that node value in left underscore nodes dot append the node dot button, and after that just traverse in left direction. Okay, and same goes for right also. So def left node and then right nodes and then leave. Oops. Okay, if not node, return, and left, sorry, right underscore nodes dot append node dot data, and after that go for right node dot right And now for leaf nodes or leaf, if not, if not node, return. If there is node, then check the condition. If node not left, was also node not right, and then the double equals to none. If this condition follows, then just add this. Then thanks, Ritik. Okay, so in leaf nodes, as defined, the node dot data, and after that, if this condition is not follows, then just go for left and right. And leaf node dot left, and same goes for leaf node dot right. Okay, and after traversing all this, we will get all the values, and just then I have to return the values of all these. So for value, it will be first we have to take all the leaf nodes. Okay, and after that I have to take the sorry, first we have to take the all the left nodes and now leaf nodes. Leaf nodes, and in leaf nodes I have to traverse from one because the first leaf node on the left will already be already in the left nodes. So from 1 to minus 1, and for let's not make complicate things. Let's just pop them out first. That will be better. Left nodes dot pop the last element. This will pop the last element, so I don't have to put the one. And in leaf nodes, I also going to pop the last element. So this will help me to not put this thing here. And for the right nodes, I first have to revise the right nodes because according to question, we are in going in reverse direction. Okay, so right underscore nodes dot reverse. In this way, it will be reversed, and now I have to pop the last element, that is its root. And I have to add them. Okay, so let's see if this works or not. Uh, Pop from empty list. Left nodes dot pop. Okay, so let's make a condition. If left underscore nodes, same for leaf. Well, there is always a leaf node. Oh, if there is no, okay, I get it. If not root, just return an empty list. But in the input, there is already some input. So this is the leaf. So according to my code, the leaf node should have 1, 2, and 4. I is not a single. Let's print it out and check what in our left node is. Left nodes. And let's also print for right nodes. And for leaf. Okay, let's run this. And let's remove this pop and reverse just to check if this works or not. Okay, so all the lists are empty. Why? Okay, I haven't called them. Okay, okay, so I have to leaf left root and same for right root and same for leaf leaf root. Okay, so let's see what we got. Mm, 36 leaf root and line.com and leaf node.left um, in left given the root. If not node, then just return to nothing. If there is if there is root, then just left nodes dot apple data. Yeah, it is right. And then just left node dot left. That is all right. Then let's make all this comment and check what I'm doing wrong. Okay, so I am getting 1, 2, and 4, and 1 to 4, that is right. Okay, it's all right. My left side is working right. Let's check for our right. Mm, for right function, and our right function is returning 137, and 137 is our right. Okay, it also working. And let's check for leaf. And in leaf, it is giving error. Uh, not dot left, not dot left. I'm just not seeing the whole error. Let's understand what is going wrong here. Def leaf node. If not node, then just return. Okay. And if there is node dot left also to if left and right both are none, then just take this its data, and if both are not none, then go in left and right. What is here? Investment. Okay. LEAF, 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 LEAF. Spelling is right. If not node, return. If not dot left, w question dot run. Okay, let's use this. Maybe this is important, right? Okay, it is giving error. What I am doing wrong in this code, I don't understand. Let's ask our chat GPT what I am doing wrong because I'm not able to understand what is wrong here. Okay, so let's put this. Okay. It is because that checks the name. What's wrong? Leaf node is not defined inside the function. You are appending the left leaf node, but it is not declared as a list before the function. Oh no, it is different. It is different. It is okay. And here leaf node is constant. Leaf nodes. Okay, wait, leaf. I need the leaf nodes, and here I'm just taking leaf. Okay. It just didn't works. Okay, it was spelling mistake. It was leaf nodes, and I have just written leaf node. So 48967, 48967, 48967. Yeah, it is taking all the leaf nodes. Um, let's comment out these print statements. And comment these statements, and let's check now if this works or not. Okay, so what I'm getting is 1, 2, 4 and 4. Okay, I'm getting 4 2 times. Oh, okay, I haven't removed from the leaf node. Okay, the first element. Okay, this case test case works. Let's hope that this will run. And it is in the first test case. So my output is 142 and its correct output is 1342. I'm missing 3. Let's see how this tree looks. Okay, so I have missed the 3. Um, okay, so what I have done wrong is the leaf node should be 3 and 4, and I have popped this 3 out, and in my left only 1 should be there. Okay, okay, so the whole mistakes done in this part. Let's understand here. Do not include leaf node in this section. So let's also put a condition here. If it is a leaf node, just don't append in the left. So let's make a condition R, and in this just add that node if not node dot left and node dot right both are not present in here, then just return. This will give the leaf node and it will not take any leaf node in the left. So now I don't have to pop out anything from my left node. Okay, and for in leaf, all the leaf nodes from left to right that are not part of the left or right boundary. Wait, what? He's telling us that don't take the left and right boundary, okay? And here it is telling that this is problem what's right. That most of you must prefer the left side over right side. Do not include leaf nodes in this section. It it is telling do not include leaf nodes, and in leaf nodes, it is saying that they are not part of left and right boundary. Okay. Here they are telling that left right boundary. Okay. So now I'm in leaf node, I don't have to pop anything. I'm taking all the leaf nodes, and I also and in right, I have to pop out the first element that is root, and I and if I have to already pop out the root node, then I just go directly from root dot right, and I also already confirm that root is there. Okay, so it will not take the root node. And for the last that is already in our leaf node, so I have to pop this guy out from the. Okay, so this pop statement should be not root dot right, and here it will be this pop statement should be in equals will be should be here. So this pop is popping out the last element that we are taking right nodes, and I'm reversing because this is guy taking in reverse. Let's check if this works or not. Okay, it works in both test cases, and let's run it. And it fails in first test case. Now let's check how this tree looks and what it's output. So this is our tree. So let's check what is the difference between our output. So my output is 125 and the expected is 12543. Okay, 12543. 125 4 and 3. Okay, so 1 is base for left, I'm taking 1 and 2, it's okay. And for right, I'm taking only 3, but 3 I was expected that it will be in our okay, now I get it. Okay, I didn't got the last I didn't got the leaf node, that's why. So these all 1, 3, 4, 5, these all should be in our right traversal. It means my right traversal is not right according to this code. Okay, so let's see um, well, how it should be. So according to this 1, 2, 3, 4, 5. Okay, 1, 2, and, 3, and then 4 and 5. 4, and is also the selections. 4. This is the output, and we are going to 1, 2, 5, 4, and 3. So in right, what I'm doing is taking 1 and 3, not traversing in left. So it means I have to not traverse more if I found a leaf node while traversing right, and if this condition is right in the right side traversal, then I also have to do same thing in my left hand traversal. So okay, so I am not to make a function again for right, and here I'm putting the node, and because I am not taking the root, I'm directly traversing to over right, because before traversal I just call it right root dot right. Okay, this is what I called, and in parameter node the thing that goes is root dot right, that is 3. Okay, in this one I don't have to remove the root from this, and now if not node, then I have to return, or there is one more condition that I have to add, that is if I go to leaf node, then just return to nothing. Okay, so mm, uh, okay, I have to make a and, so not node dot left and not node dot right. If this condition follows, then just return, and if this condition not follows, then take that node value first. Okay, so take its value, whatever it we get. So that will be no, sorry, it will be right underscore moments, and then dot append that node value. Okay, and after this, if right uh, if right node is there, well, as you can see, according to they are seeing boundary. Well, if it is boundary, it means it is a left view and right view. Let's see what this course will be work out according to what they are saying. If right node is there, then just sorry. Okay, here. If node dot right is present, if node dot right is present, then just go for again right node dot right. If right is not present, then go for left. Okay, and because I already checked this condition, so I don't have to check if node and right and left both are null. Okay, so let's go this and check if this works or not. And because I have to do this thing in right, so I also have to do the same thing in my left side also. I'm not going to input it. Now let's write it in a way. Input left that is custom moment dot right custom moment. And then just return and then append the data. If no dot right is there, then just go right. And if not present, then go left. Okay, this will be our code for right and the same code for our left also. Else, left, right. Now let's see will this get our output or not. Okay, all the test cases we have here. The output should be 1, 2, okay, 1, 2, 5, 3, and I'm missing 4. 4 is in this. Yeah, 4 should be in there because while traversing any right. Okay, okay, nothing I have to talk about. Again, the first case we have passed, but now 1, 2, 5, 3, 4, and answer is 1, 2, 5, 4, 3. My output is 1, 2, 5, 3, 4. 1, 2, 5, and then 3, and then 4. Why? I think, okay, I haven't reversed the right notes. Let's start. Now, two test cases are getting right answer, but in test case 2, I'm not getting. According to my output is 1, 2, 3, 4, 2, and expected is 1, 3, 4, 2. 1, 2, 3, 4, 2. 1, 2, 3, 4, 2. So, why I'm going in why I'm getting two times? Mm, okay. Okay. So, for as I have done for right, let's do same for root dot left, and add the root in the first. Okay, left node, leaf node, right node. Okay, our test cases pass. Let's see if this works or not. And again, we have failed. My code output is 1, 1, 2 times 1, and it's correct opposite. Let's see why this is happening. And this only root is available. Okay. So if okay, okay, if only root is available, then it become already leaf node. So go for leaf root only if, let's make a condition here for root, if root dot left or root dot right. There should anyone should be available to go find leaf node because I'm already adding the main root node. Okay, my test process pass. Let's run this. And here we go. So in 4 attempts, I've solved this question using the recursion. And now we also have to solve the same question without using recursion, only traversal. Okay, so we have to traverse 9 times. One traversal for left, one traversal for right, one traversal for left. Uh, let's do this because we already know the recursive solution, and it is pretty easy to understand how to write its traversal code. That was the first. Okay, so in traversal again, first 4 line will be same. And after this for left, um, they are using, let's use the DQ. Okay, I have to make a queue, and in queue, I have to put, okay, first I have to check if there is a, I can, if there is root dot left is present, then do these things. Q, DQ, and then invest root dot left. Okay, because here we are traversing from root dot left, and in traversal we are checking if not node. Okay, so now we have to make a while loop, while q, and then just pop this out, and node is equals to q dot pop left. This will pop the element, the first element, and now I have to check these conditions. Okay, I have to check for this condition if node dot left. Let's do not check if condition. Okay, okay. What was that? Okay, I don't remember the shortcut. Okay, so if node, the first condition if node, if not node, or the same condition that we have here, but in the place of return, we are going to put continue. Okay, and the same thing that we have done here. Okay, is in left node append this data, and if node dot left is there, then just append this in our queue dot append, and if not present, then go for queue left, sorry, right direction, and now we have to move for left, and we have to do the same thing for right also. So here we will put right, pop left, but not continue, if left not dependent button. In the left node, we have to put the right, and if right is present, then go towards right, then not right, then go to left. Yes, so this is our for right, done for left, done for right, and let's see what code was for leaf. For leaf, we have checked this condition first, if root dot left or root right. Anyone is present, then run for leaf. So let's check if root dot left is present or root dot right is present, then go in, and after that make a queue equals to dq with the value is what we are, okay, the root while q, and if there is q, then if not node return, if not node, then just continue, and if not left, if both are not there, then just append that. If not, node dot left and not, sorry, not use node dot left double equals to node dot right double equals to none. If this condition follows, then just add this guy in our leaf underscore nodes dot append the node dot data, and after that and continue, and go left and right both direction. So q dot append node dot left and q dot append node dot right. Okay, this will get our answer, and now I have to reverse the right nodes dot reverse, and after reversing I have to return the root dot data. After this, left underscore nodes plus leaf underscore nodes and then right underscore. Let's, okay, let's see if this code works or not. And runtime error. The program took more time than expected. Okay, I think there is in some place while queue if left and right is available. Okay, okay, okay. Because if not root is present, if if we let continue and in here while queue, here optimizer for submit. I think there is something that I'm missing here. Let's ask Yogi bot. Code is too long. Seriously, what a great output. Code is very long. Okay, so then let's see. Left nodes, right nodes, leaf nodes. Q is equals to dq dot left. While Q, I just pop left, and after popping, if node is not there, or it is null, don't do anything, or let's see which one is doing this. Let's see first one left. Is this giving the TLE? Okay, now it is not giving TLE. Let's check for right. This is also not giving TLE. And now let's check for um, this. Okay, so there is something is not right in my leaf nodes. If not node, then just continue. If node dot left and right both are none, then add that guy and then continue. Well, according to me, it's look normal. Why it is taking more time because okay, while queue, I'm popping the okay while queue, I'm not popping out here. Okay, and I failed in test case one and all test case ones. Okay, let's see why I failed. 1 2 4. Okay, my output is 1 2 4 6 7 8 9 3. 1 2 4 6 7 8 9 3. 1 2 6 7 1 2 4 6 7 8 9 and then 3. Um, why it is giving 1 6 7 8 9 3. 6 7 8 9 3. Why not putting 6 7 first in place of 8 9? I don't get it. I'm taking 6 7 first before taking 6 7 first and then 8 9. Okay, so I think because I'm using Q, so I'll just put left and right. And as I get to, I go to 8, 9, I I go first in 6 and 7. That's why. Okay, so to solve this problem, I have to use the stack in place of Q. Stack, stack, stack. Not left. My was going to use part. Append is same, but now I'm going to append the right first because I want to traverse in left first. Okay, and missing anything? I don't think I'm missing. Let's try. Okay, so now because of this, all test cases. अरे अल्ताफ DD. Okay, so where we are? Here, okay, don't like you. Bottom element stack. I'm using stack and still, because of some reason, I'm not getting the right answer in all these cases. And and because of some reason, my output is also decreased. 1, 2, 3. I'm not getting any leaf node. Why? Let's print out like let's check if print all the leaf nodes. I don't think it is returning any leaf nodes. Yes, it is not returning not a single leaf node. But why I have this stack? If root left or root right any is present, then go for stack. In stack I put the root and I run the loop, and in loop node start of top about this guy out the last element that is root, and then check if not root this will continue. If this condition follows, no, then just append the node left or right. Why it is giving me nothing? Let's see, print more, not like I dot data or I in stack. And if I if I Okay. I think I have to put this in the list. Okay, it is giving only one, and here one, here also one. So I'm not traversing in stack. Why? Let's see. If no, I just popped this guy out from this node. Okay, no worries. Okay, I am using Q seriously. Stack. And all test case passed. Let's submit, and it works. Okay, let's see other solution. Maybe we can get a more simpler solution because this code is very like more than 14 lines of code. Let's see if there's any comment in which they have given a more better solution. Okay, I think in the editorial you can see it. Okay, now this guy also have used print leaves, print boundary leaves, print boundary right. Okay, for right, for left, and also for boundary traversal. Yeah, this guy has also make the same thing that I have done. Yeah, there is no other solution it means which can decrease our code length. Okay, so let's go for our next solution. That is as a question. It is vertical auto traversal of a binary tree, and it is a hard question. This is the first hard question that we are going to do. Let's see how much time it took. And it took 1 hour, 8 minutes to solve that question. And that poor question comes in. Don't tell me it is an easy question. Okay, it is medium question, thank God. I don't it was they put that question this question in easy. Okay. Okay, so let's see. Vertical order traversal binary tree. Given the root of the binary tree, calculate the vertical order traversal of the binary tree. For each node at the position row and column, its left and right children will be positioned at left row is +1. Like row is increased, the new row is same, and the column -1, column +1. Okay. The vertical order traversal of a binary tree is a list of top to bottom ordering of each column index, starting from the leftmost column and ending at the rightmost column. There may be multiple nodes in the same row and sequence. In such case, these sort these nodes by their value, return vertical order traversal. I think we have done it. Let's see. Um, we took the 9 and then 3 and 15. Okay, these guys are taken this way, like up down, from up top to down. Okay, let's see how we can solve this question. So let's copy this image and let's paste. Sorry, completely. And after pasting, I have to do text mode, text mode. again. What the hell? Okay, here. Okay, what we got here is 329. So, what they are doing is just giving output in this way. Oh, sorry, 3 and 15. Yeah, it comes like this. And if there are two in the same level, like 9 and then let's make it 10, and 10 will take 0, 1, the height is 2, and minus 1 will become 0, 2 comma 0. 2 comma 0 and 2 comma 0 got for both 10 and 15. So in this case, I have to sort these values. So if they are taking first is row and second is column, then we just let's make a dictionary map. We have to make a map which contains the column and then um, sorted with the list will contain first value, no, row and then value, row and value, and this will be in sorted condition. In this way, we have to make our dictionary. So for each column, we will get the sorted value, and then we just have to put out the values and return like mm, in return condition. We just have to put like because it is a dictionary, traverse in dictionary, and uh, okay, key comma value pair. Not that. Not me. Okay, let's don't write a one-liner. Let's write the code. Like our answer is equals to this, and for key underscore. Oh, okay. I also have to get the sorted C. Okay, so here we will get the columns for call in our dictionary dot keys. This will give our all the keys, and I also have to sort. Oh, sorry, sorted, and then sorted for each column. Just answer. No, not answer right now, because in each column there are values. So for the first is row and then value in our dictionary with column, whatever column it is, and then just put the answer dot append values. This this will be our answer. Okay, so we have to traverse while taking row and column with us and appending these values in our dictionary in the sorted manner, and when we traverse in our home, then we have to just return this answer. So to traverse, I think it is going to be very easy to traverse in this. In traverse, we just have to get our root and row, whatever row in it and whatever we unfollow element, and just uh, update the dictionary according whatever the condition it is, and uh, and after updating, just traverse in traverse in left with the row plus one. That is always row always gets plus one whenever we go down. And for vertices, if we are going to left, then we sorry, not v, it's c column. Okay, it's c minus one, and for right, we have to do the c plus one and all the same thing. Okay, I think let's code this. This is going to be our first question, first hard question that I'm going to do of tree. Let's see if this work out or not. Okay, we have to make a traversal and a dictionary. In dictionary, let's name it D dictionary, and in dictionary, we are let's here we comment this thing, like in key we are taking column, and in value pair it's sorted key value pairs, that is sorry, row, and then whatever its value. Okay, in this way our dictionary is going to be made. Okay, so this is how we are going to make our mapping. Let's make it a little bit more good looking. In place of t, let's make it mapping. And now we have to traverse in our, they have taken root, so we have to take note, and row comma column, and after this in a node, if not, then just return, do nothing. If there is not, then just put this in mapping. And yes, in dictionary we are going to use default dict, so our code will look a little bit smaller. So from collections import default dict, and then default dictionary, and in dictionary we are putting list. Okay, so we will solve this after while after traversing. Okay, mapping dot sorry, mapping, and in this column, and in column I have to append append the key value pair, that sorry, key value is not row and value. So the row will be row and the value will be node dot val, and after this mapping I have to traverse in left and right. So traverse in node dot left, and row is always going to be going to increase, and for column, because we are going in left direction, let's it will be decrease, and in traverse node dot right, row plus one as always, and column plus one. Okay, this will be our traversal, and after traversing I also have to sort these list. So we will go in each um, for Okay, let's make its answer directly. So let's make a answer array, sorry, answer list, and in answer list for I have to column in uh, sorted keys. We have to take the mapping sorted keys. Okay, so this will give the sorted keys of columns, and in sorted, we have to go in each column for whatever is list we have. Um, for sorry, row and value in sorted, and this is called from mapping column. This will sort our uh, array, and sort it will first sort according to row, and after that it will sort according to value, because they already have made there may be multiple cases in same row and column, in such as sort these nodes by their value. Okay, so value will be sorted according to its whatever their value is. Okay, so I just have to put these value in our answer dot append, and let's see how the output is. They're taking output in the list form. Okay, so it means we don't have to here we have to get row and value, and I just have to answer dot x here, answer dot append this whole thing. Okay, I have to sort, and I have to sort these and get the values only. I don't want row in our answer, and then just return the answer. This should be our goal, that I think it should work. It is a hard question, and after seeing this small code, I think it will not work, but let's see. And here it gives an error. Let's see why. And syntax error. Okay, thank God it is a syntax error. Let's see where I'm getting. Okay, there is one bracket is less. One bracket is for sorted, one bracket is for this list, and one is for this. Okay, let's run. And my answer is wrong. My output is null, and I don't know why. Well, I am traversing. Okay, okay. I have sorted the keys and that is the column. Okay, let's see our dictionary first. Okay, so let's print our mapping. Is there anything in our mapping or not? And in our mapping, there is not a single list. Okay. Oh, okay. Oh, bro. Again, I'm doing the same thing. I haven't called this function. Seriously. Traverse, not its root, not, and row is also zero, and column is also zero. And this time it's I don't know what this error is. Let's see, type error, type error. Um, the output should be list integer. Okay, I think it should be in this way maybe. Okay. Yeah, same. Because I was returning tuple. I am appending tuples in it, and that's why it is showing the error. And all test cases passed. I don't know how, but it passed. Let's see if this works or not. And it works, bro. It works. It is a hard question and it still works. Wow. I didn't expect that it will work in a single run. Seeing this question now, there's something extra that they have said. So it was really an unexpected thing for me to run a hard level code in a single run. Okay, now we have to code the same thing using without using recursion. So the answer is should be in a same way. So let's copy and paste because we have to make a dictionary and our mapping will also be in a same. And now the difference will begin here. So we are traversing, and because we are taking the row and columns, so it doesn't matter we use a stack or queue. So let's go with stack because stack can be made with our default list. Stack and in a stack and because they have already in constant there is already written this all there will be not a condition with zero root or zero nodes are there. So we don't need to check it. So stack and there's always a root available. Okay, so we have put a root while stack and root sorry node equals to stack dot pop and after popping if not node just continue and and then just in okay in root also I also have to give the row and column. Here I will comment and so what is root, row, and column. If not root, do nothing, and in mapping. Okay, so and now I have to append this guy, and here we are taking node, comma, row, comma, node, comma, sorry, row, column. If not node, just continue, and if there is node, then just append this guy in our mapping with what was that in one mapping column and with column dot append the values that will be a row and then node dot value and after appending just I have to traverse in both direction. So start dot append. In append, I have to put the node dot left, and because I am going in left direction, the row will be 0, and sorry, row will be row plus 1, and the column will be -1. Um, and off second, I have to go right. row plus 1, but call plus 1. Okay, so this will complete our code. Let's see if this works or not. And it works. Let's see, and let's submit. This code was way more easier than this medium level tree boundary traversal. I didn't expect that, but it worked out. See, the previous question, it took 1 hour, and this question took only 30 minutes. And let's see this question. Uh, let's see if there is any other way to solve this question. And solution for Python. No, think I'm doing the same thing, taking note and appending this. Okay, and notes dot sort. So it works in a similar. I made the dictionary and they just made the like column, row, and then node value. That's same thing, nothing different. In the place of like dictionary, they use the. Okay, so let's go in our last question for today. The diagonal tree traversal. Given a binary tree, return the diagonal traversal of the binary tree. Consider the lines of slope -1 passing through node. Given a binary tree, return a single list containing all the diagonal elements in a binary tree that belong to the same line. So 8, 3, 8, 10, 14, 3, 6, 7, 13, 1, 4. 8, 10, 14, okay, and then 3, 6, 7 is 3, okay. So, here is the question of how they are, okay, they have given 8, 10, 14 years in the line, and then 3, 6, 7, and 13 they have took. Okay, let's read the code, maybe it will give more things. Consider lines of shape -1 passing through node, given a binary tree, return a single list containing all elements, okay. With the diagonal elements are present in two different, there are diagonal elements occurring to different subtrees. The left subtree diagonal element should be taken first and then the right. Okay. So shows they have shown. Let's copy this image. Go for our next code. Back over here. Paste. I will add this text model here. This okay. Yes. I will add this text model man. Shortcut. It is difficult. You are going to click on text model again. Okay, so let's first see the row and column. So for A, it becomes 0, comma 0. I'll be taking first row and then column. So 0, comma 0, and then row will be 1, and column will be minus 1, and row will be 2, and here will be minus 2, and here will be 1, and here will be 1, 2, and 2. Here will be, in place of 1, it will be 2, and 3, 3, 3, and it's 2, then now this will become minus 1. We are going to write direction, it is 0, and this will become 1. And here to 0, and this will become minus 1. So let's see what is pattern here. Here and it's 1. So 0, 1, 2. Okay, and 0, 1, 2. Okay, so no problem. And here it's 1, 2, 3. Okay, it's always in increasing order. And the the column, and the column is minus 1, 0, and 1, minus 1, minus 1. And here the column and both are same. So if both are same, then just take this. So and now the question arises like how we are going to solve this. Hmm. So the should I make a dictionary with I have to save this value in traversing. I can traverse 367, but I will not get the 13 in that. And if I traverse, mhm, this is going to be a difficult question. The single line output is 1 to 3, okay. And where output is you can see what is. And one thing, like in our answer, the list of uh, we can make a list of each traversal, and we have to put like from where this is starting. Oh, I think ZFG medium question is more difficult than late code. Hard question. I don't know how to solve this right now. I'm not getting any ideas. Okay. Let's see what we can do. Like we can make a dictionary that starts with 0, comma 0 as and if it start with 0, comma 0, then one thing that you can do it is 0, comma 0 and the value is 8. And as we traverse it become 1, comma minus 1, that will be 3, and then 2, comma minus 2, that will have 1, and then 6, oh sorry, 2, comma 0 with 6, and 3, comma minus 1 with 4, and 3, comma 1 with 7, and because 3, comma 1 is into this, so it will become 13 also, and 1, comma 1 it will become 10, and for 2, comma 2 become 14. So like 0, comma 0 it's 8, and what we get 8, 10, 14, 8, 10, and 14. So we took the 0, comma 0 first and then just increment it. So after increasing it, it will give up this guy and 0, comma 0, 1, comma 1, and 2, comma 2. Now in our dictionary, only these guys will remain. And now we will find out the next, the smallest element that we can find, I think. And the next smallest element in these in this will be the row can be 1 and minus 1. 1, comma minus 1 will be the second smallest element, and the second will start with this 1, comma minus 1, and 1, comma minus 1 will take 4 guy this, and 2, comma 0, and then 3, comma 1, and after this we will find out the smallest element again, and the smallest element is 2, comma minus 2. Okay, and we will put this guy out 2, comma minus 2, and then go implementing it, and in this way we will get. So the thing is we have to make a dictionary. Okay, and in that dictionary we will put these things, and after the dictionary we have to make a list which contain all the keys in the sorted manner, and run the loop. So our code should be, so let's write the code. We have to make a dictionary. Let me make it big, and we will make a default dictionary, and we have to traverse in this whole array. So def traverse, and then we also have to put the root with its value like row and column, and in this way After traversing, if not root, then just return. And if there is a let me have some water. Okay, so if not root, then just return. And if there is root, then just take that value in our dictionary, and dictionary's key will be dictionary key will be row and column, and we will put it in tuple, and tuple can't, is immutable, so it will take it as a value and append whatever the root dot data, and after that just traverse in left and right. Root dot left, and row will always increase and column will decrease. And in this using this traversal you will get over this thing. And here comes the the real problem, and I think we can solve it. Okay, so now we have to m- make an our answer array. Okay, and then in for loop we will take our key value pair, sorry, row column, row and column in sorted sorting d dot keys. Okay, and and if here we check if R comma C in our dictionary, if R comma C in our dictionary, then we just then what we have to do is um, first of all we have to append this in our answer, but before appending we will find, okay, where it is. Okay, while R comma C in our dictionary, while it is in dictionary, then just first just delete d comma c. This will delete the row column, but before deleting we have to get its value. So get its value in our answer dot extend. I am using extend because this can contain the links. So we will put these all element in the list. Okay. So answer dot extend. Oh, hello Vivek. And so answer dot extend we will put the dictionary values D with R comma C. And after doing this, we have to remove this R comma C value, sorry, key from the dictionary. So delete D or comma C. And after deleting this key, we have to increment our uh, like not we don't have to do anything. Yeah, we have to increment because we have to find this line. So R is equals to R plus 1 and C becomes equals to C plus 1, and this will give our answer, and you just have to return our answer. So maybe this not maybe because we have sorted these guys out, we have taken, and then we are traversing in this and removing these things, and we are because we are removing this from people using the while. So if this R comma Z is not in it, then we do nothing. Okay, let's code it out and let's see if this works or not. Okay, so we have to make a dictionary, and let's make it name, change its name with mapping, and we are going to use default dict to make our code a little bit shorter and clean. And then after default victim, we have to make our function that traverse in our whole uh, node, and after node it row and column, and in row and node, if not node, then just return, and just take its value, append it in mapping with row comma column dot append the node dot data, and after this just traversing left and right, so traverse node dot left, and while in left, row will always increase by 1, but column will always decrease by 1 because we are going left, and when traverse in right direction, row as always increase by 1, but column will increase by 1 in this case. And after this we got our like traversal is complete. Now we have to make our answer list, and for row comma call in sorted mapping dot keys. Okay, uh, after getting the keys, and after this what we have done, we are going for while loop, while row comma call in our dictionary, that is mapping, and we just have to put answer dot extend with what was that mapping, whatever the value contains in mapping, that is row comma column, and after this answer dot extend, and just we have to delete the key, delete the mapping, and the keys row comma column, and after deleting it we have to increase row and column with plus 1, row plus 1 comma col plus 1, and this will get our answer, and we have to return our answer. Okay, let's see if this code works or not. And my output is nothing. Okay, because I haven't called this traverse. As always, I forgot to call this. Input comma row will be 0, call will be 0. And the output is okay. Let's run. And it fails in our test case 3. Let's see why we are failing. And the reason is 192369. Okay, so in my case, 21 comes before 11. Um, Everything is not right now. 11 and 21 are interchanged. Let's see why. Okay, here there is no. Okay, so mm, and into record test case. Button there. Don't put it. Okay. Yeah. Yeah, trim this. Okay. Trim this. Okay. This is our tree, and the problem we are facing is uh, like, let's see the problem what we are facing. So the result in case 2 is the expected. The 11 comes first and then 21. 11 comes first and then 21. In my case, the 21 comes first and then 11. Okay. So let's make it um, let's take it as a screenshot. With an image. Content. And let's paste it here. Not pasting. Now, okay, this. Okay, let's see what is going wrong here. Let's first put the values here. 0, and this will be 1. This will be 2, 2, 2, and this will be 3, this will be 1. And for for columns 0, 1, and then 0. This is 0, then minus 1, minus 2, then minus 3. It's minus 2, minus 1, and again minus 2. And, minus 1, 0, 1, then 3, and this like they have made this. Okay, let's remake it again. It doesn't look good. 19, and after 19 they will put 6 and 23. Okay, and after that 21. Let's put first 9, and then 21. What we can do, 9, 21. Okay, so 9 and 21, and after this from 9 there comes a new line. It is 11, and then for 9 it's plus 9 1, it's 8, and then one new line, that is 7. Okay, and from 6 it's 9, that is 3, and 1 comes here, that is 5 and 8. So 5 and 8, and the 7 is from 8. Okay, and 3 it's 2, and from 5 also comes 1 4, 4 and 7, 4 and 7. From 5 it's 4, and from 8 it's 7. Okay, so according to the question, the output should be 19 and 23, and then 6 9 21, 6 9 21, and 11, and 3 5 8. Let me change the color. The first is this, and the second is this, and the third is this, and fourth is this. So our output should be 19 23. Wait, let's let it be here, and the output should be 19 23 6 9 21, and 11, and then 3 5 8, and then 2 4 and 7. Okay, so this will be our output, but what I'm giving output is 19 23. 19 23 is okay, 6 6 9 is also okay, and then My output is 21 and 11, and that is what I expected to get 9 and 21 and 358, and all things are right. So, according to the question, this will be not in this way, there will be 11 and 21. And for the reason that they have given is that 21 should be first and then 11. 21 should be first. Yeah, 21 is the first. Okay, they are giving 11 first. Okay, okay, so 6, 9, 11, and then 21. But if these both guys have same column, so what I have to do here 9 and 21. So 6, 9, they are taking 6, then 9, and then 11, and after that they are taking 21. Let's understand our question again, why they are doing this. If the diagonal line represents two different subtree, then left subtree diagonal element should be taken first and then right subtree. Okay, so they are taking first left and then right. So what we have to do here, in place of extending, we also have to okay, we have to make some changes in here. And after answer, let's make a temporary list. Okay, and before extending, in place of extended, will check. We will first get the value that whatever value we are getting, its value is equals to mapping, and in mapping row comma column, and in value row comma column, uh, if length of value is 1. No, 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 no. Here we will remove this mapping and extend. Okay, in place of answer dot append, and here we will put the um like value. Let's put the value list. Okay, and in value comma append val dot sorry val list dot pop. No, the it will pop out the last element. Okay, if val underscore list is greater than 1. Wait. Val, mm, val is equals to val underscore list dot pop. No. It will increase the complexity. Let's check directly. Okay, that will be more better way. If length of val underscore list equals to 1, then just append this guy in our answer. So answer dot append whatever in val list, val underscore list dot up, and if it is not equals to 1, it means it will be equals to 2. So just and there may be a possibility of like here we can see like 5 and 8, like 4 and 7 have the same values. So there may be a possibility like there are more values having the same value. Like 5, from 5 we get 4, from 8 we get 7. There is a possibility from 2 we also get a value like 1. So now there are three values here. So this will become a little bit complicated. Okay, so to solve this, if it is 1, then just pop this guy up and do nothing. If it is not equals to 1, then just make a new list and append that list in temp. So temp dot extend with val underscore list from 1. And let's reverse this temp. Sorry, not a val list, val underscore list. Val dot list dot reverse. Okay, and after reversing, we have to extend it. Extend, no, after reversing, we have to remove the last element. Here we have pop this dash guy out, and in temp, we have to append the val list. Okay, after appending, everything is done. So now we will while temp. Okay. Common and wow, I didn't expect that it's going to be this difficult. If we get in temporary file, if in our temp we get like 1, 2, 3 a list, and then 2 comma 3 and then 1. So then what we have to do, just pop these guys out first, then pop these guys out first, and then pop these guys out first. It was being, oh my God.
Like without, I think there's a way we can do without doing this whole thing, this sorted thing that I just thought about it. Just sorted. Like in place of like we just traverse, like in 0, 0, we make dictionary we will make, but in place of this, we just like we don't have to this whole thing. So, let's try to put this thing first out, and no, it will become very complicated. Like first remove these first element, and then these element, and here also there's no confirmation like I am giving the right output. So this case fails. So this way is failed in solving this question. So I have to make a new way that I just thought of it. And that is, let me show you what I thought. Okay, so what I'm going to do, like, let's make a dictionary as always, and we will traverse, okay, the um, def, fun, and then will be a root, there will be our row, and our column. Okay, we will traverse, but in this time, I will show you what we are going to do. If not, so just return. Okay, so now we will check if there is a, row comma column pair is present, if row minus 1 comma column minus 1 in dictionary. If this thing present in our dictionary, then um, uh, okay, again I got stuck. If this thing present in our dictionary and I am on like 10, so what I'm going to do is I want that we have to make this thing it's normal, but if there is already a pair is available, then oh my god, your voice is too low. Please use different. Oh, okay. Well, I'm using my earphones and I'm listening. In that, I'm like I connected it to my phone and checking like is my voice is audible or not, but I can listen my voice clearly. Okay, well, I will find a different way to do this. Find a different mic. I have to buy a mic. Oh, thanks for telling me, MJ coaching. Okay, so I have to traverse and row minus one, column minus one. We are checking the previous. If previous is present, then put this value in it. Okay, now I think I get it. Yeah, if the previous is already present, and then what we will have to do, then just append this guy in our list. So D row minus 1, comma call minus 1 dot append the value, whatever you got, that is root dot data. And after this, and I also have to make a D with row comma call, and in this, what I have to do, put the like put the pointer of the this dictionary. Okay, and all minus 1. In this way, even if I update this, it will automatically update this. And after dictionary, we also make a list. And if it is not present, we will go in else condition. We will make a new dictionary. Okay, new dictionary with row column, and make a new list here. One list with row dot data. And after this, I will take this pointer in our list also. Okay, and by taking all the pointers in the list, we know how many lists are there that we are making. And dictionary is taking all this row minus one, column minus one, and traverse in left and right as always. So it will be same. And after this function, we we just have to merge all the list present in the list. Okay. Okay, so let's code it, because the previous one, here it will become more complicated. So we will move extend complete problem. Okay, so this is a problem, and make here not. not complete. And we now found a new way of solving this question. Mapping with root. And let's see if there's a case of 0. Yeah, there is no case of 0, so we can put, okay, mapping. And what we have done is make a function and mapping and uh, list, list of list. So let's make it answer list. Okay, so now we have to make a function which will traverse in this hole and make it node. And in node, if not node, just return to nothing. And if there is node, then what I have to do is, okay, if uh, if row, say with node, there will we have to also pass row and column. If row minus 1 comma col minus 1 are in our mapping, if these both things are present in our mapping, then just so row minus 1 col minus 1 in mapping, then just what I have to do, let's see again. Okay, I have to append this value in our mapping row uh, that map row comma col equals to mapping sorry, mapping row minus 1 comma col minus 1. And after this, and after this what I have to do is okay, so mapping row column mapping minus 1 col minus 1, and yes, mapping again row comma col dot uh, append the whatever node dot data. Okay, and in else condition, and if in else condition we have to make a new mapping with row comma col, and we will give it a list, and in which node dot data will be there. And this also we will append in answer list, append the mapping row comma column. Okay, and after this I have to just traverse in left or right. So traverse node dot left comma row plus 1 comma col minus 1, and then traverse node dot right comma row plus 1 comma call plus 1. Okay, after this, what I have to do, go left and right. Go left and right, and just merge the list. Okay, I have to merge all the list, so uh, return the list, whatever list are present. So I will take it as L for ln answer underscore list. So maybe I don't know if it will work or not. Okay, so iterable unpacking cannot be used in comprehension. Okay, I don't know if it's title. Unpacking can't be done otherwise. Okay, so I have to make an answer, and for answer for in answer underscore list, and answer dot extend with L, and after this that answer will be your answer. While which line 55. Let's see, comment. And both there is something. Okay, I haven't called it again, bro. Okay, so travels root comma 0 comma 0, and mapping row comma call list indices must be integer or slice, not tuple. Huh? Mapping. Oh, okay, sorry. Mapping is a dictionary. I have put it as a list. Okay, what this there is file selection 150 table modification. Okay, table 000, and it is not showing any error. Like, I don't know where it is. Let's ask Ruby. There are also get the problem with the recursion call traverse on line 24. Okay, TRAV. Okay, spelling mistake. Okay, so let's run this code. And it failed. And no, 37, 40, and then 4, and then 36. It told me like you should take precedence in left, and I'm doing it, and it's still getting wrong answer. Yes. Okay, so mm, this is what we are visualizing, and okay, I will take a little break for like 5 minutes.
Okay, so let us start. I had a call, so it took a little bit more time. Okay, so what we are doing here, and it doesn't work the way I wanted. So in 4, it 37. Okay, here it's 20, 45, 46, and this goes in 16 and 36, 6, 12, 37, 14, and then 36. 436, 436, here is 4 and 36. These both, okay. And what I'm doing is, okay, let's first make this graph more clearer, okay. So in graph, it's 20, like, let's make it here. Is there any way to insert a tray? Share. Oh, it's a table file window. No. Okay. Okay, 20 and then 3 and 45. 3 and 50. Okay. And after that, in 45, 30 and 46, 38, 46, and 37, 41, 47, 41, and 40, 43, 40, and 43. Okay, and 55, 56, 30. Okay, 38, 38, 38. Right, okay, here. So 38, 41, 40, 43, 38, 37, and 36. And okay, answer is 10. Let's go for here. So here it's comes 7. Okay, 7 and 38. Okay, and this line will come for 38. It comes 7. Okay, and 7 where it comes 7, it comes with 14. So here 14 and 41. Yeah. So 14 and 41. So this will merge to here, and 7 will merge to this guy, here, comma, comma. Hmm. And 14 is 16 and 12. From 14, there comes 16 and 12. For 12, it also 12 and 43. 12 and 43. From 41, it comes 43, and from 14, it comes 12. And these are also the same. And 12 is there. Uh, okay, 16 was in this direction. 16. And here are 12 and 40. 12 and 40. Mm, 12 and 14. 12 is connected to 14. And from 41, it's connected to 14. Okay, and 7, 6. 7, it goes 6. 6 and 37. So 6 and 37. From 38 it comes 37, so it comes 6. And from 37, 36 is connected. And 6, 4 is connected. That's inversion. 4 and 36. 4 and 36. So from 6 it goes 4, and from 37 it goes 16. Okay, so the graph is something like this. And I have to make arrange comparison calculator. Okay, so this is our tree. So the output should be 20, 45, and 46. 20, 46, and then 3, 7, 14, and then 38, 41. And okay, let me something. 20, 45, 46, 3, 7, 14, 16. So 3, 7, 14, 16, and there is 38, 41, and 53. And same goes 6 and 12, and 37 and 14, and 4 and 36. So this is how it goes. So this should be the output. And let's see what is not gone here wrong. So the output 4 and 36 should be last, and my output is going 40 and 36. 40 and 36. There is 40, 40 and 36. Okay, so let's take this input in our question input, and for output we will print the answer list, answer underscore list. Case 3. Here is come 20, 45, and 46. Okay, nicely done. And then 3, 7, 14, 16. 3, 7, 14, and 16. And after that, 38, 41, 43. 38, 41, 43. Nicely done. 6 and 12. Okay. And then uh, 4 is in different case. I put 4 in different, and 37 comma 14 different, and 36 is also different. So the question is why? Like in this should be same. Okay, let me see. Okay, I haven't added that condition. If the same condition follows, then what I have to do? So in that condition, I have to make a new here. L if mm, if row minus row is empowerment. Wait. What? 23, 44. So how should like they are taking? If already a previous node is available, then do this. So it means like 4, 6, and 12 are not matching in that case. Okay. Okay. Now I get it. If it is already here, uh, if this row comma call is present in mapping already, then what I have to do, I don't have to make a new map. Okay, I just have to append in the list. Okay, let's see, is this what environment? So in case 3, it 6, 12, 40, 6, 12, 40. first check for previous columns. If that is in here, then do this. And if that row column is in mapping, then I have to do. So in new thing, what is going wrong? Okay, 6 12 44, 6 12 44. Like row and column. The new row and column is already don't know what is going wrong here. Um, if previous node is present, then just do nothing. Just make a new map. Okay, and if this is present and okay here, if -1 is present and row comma call not in mapping. If it is not in mapping, then make a new 6 12 40 6 12 40. Oh my god, again. Ah, now I got stuck in medium level question. Not in hard, but in medium level question. Seriously, bro. Uh, if I know that the previous node is present and my this thing is not present, then I have to make a connection. And after making connection, I just have to append that data in the mapping row and column. Okay, and if this thing is not present and then do this, and here also make a condition if row comma call not in if it is not in mapping, then you have to make a new list. And if if it is present in the Pokemon not in mapping, then do this, and it is in. Oh, okay, okay, okay. Uh, this is condition if uh, if comma call in mapping. If it is not in mapping, then do this, and if it is present in mapping, then just answer dot list, sorry, answer underscore list dot append the mapping, sorry, append the not dot data. Oh, not an answer list, sorry. In a mapping, in mapping, row, comma, column, dot append, dot data. 6, 12, 37, 40. Let's see. Again from starting 20, 45, and 46. Nice. Then 3, 7, 14, 3, 7, 14. And then 16, 38, 41, 43, 16, 38, 41, 43. Nice. 6, 12, 37, 40, 6, 12, 37, 40. Nice. And then 4 and 36. Correct. Okay. I think this completes our code. Okay, now we can answer. Mm, yeah, all distress response. It's 57. And it failed again. Bro. Now let's ask our chat GPT what I'm doing wrong. This was my previous map is present. Code too long? Seriously? Let me ask the chat GPT. Maybe this guy can solve our answer. I see you're trying to work into your computer diagram towards my tree. Promising a wrong mapping log. They're like an traversal whose diagonal traversal is determined by row minus column or just column code. Condition row minus min column is nothing. This is not how dynamic are related. We should use a single like row minus column for collecting nodes. Flattening in the end, the problem usually expect result as a list of lists, not one big flattening list. If you want flattening problem, you don't waste on the list at all. So the correct output is this. So you're seriously think it will work now. Let me check. After spending this much time, if this code works, well, really. Mm, shit. Please, no, please don't work, please. Shit. So what this guy has done, if not good, okay, table default, node row. Oh my God. Seriously, just this thing. Why hasn't thought of this? Let just diagnose as this like 0, 1, 2, 2, 2. Seriously, bro, each diagonal have the same keys. Mm, okay, let's code this in traversal. Uh, okay, if I didn't know that the diagonals can be taken as row minus column in tree. So if I knew that, so it will be very easier to solve this question. So now let's make a traversal solution for this. Mm, if not root, just return the empty list and diagonals. Let's use, well, it doesn't matter. I will, no, it matters if you are using stack or not. I will use a stack, uh, root comma 0, comma 0, and stack, and here we get node, comma, row, comma, column is equals to stack dot pop, and after popping, if like we have to map, find the t, one, okay, t, this is row minus column, uh, okay, I have to just set diagonals minus t, so t that is equals to row minus column dot append the node dot data, and if not node, sorry, not return the continue diagonal, and after diagonal just go left and right, and because we are using stack we are going first, right? So stack dot append node dot right, comma, row plus 1 as always, and call minus 1, and stack dot append node dot left, comma, 1 plus 1, comma, call plus 1. And after doing this, all our stack will be open, and now for answer, are you done? Mm, I will come after 40 minutes. Okay, so normal stack dot open points answer mega list for, so what this guy is for key, for key inserted tag colony diagonals dot key concept dot extend the whatever in our key return access. Now listed upon the text. Okay, so I think let's see if this works or not. And again error. Okay, sorted out. Let's stop. Person not default the object has no attribute key. Okay, keys. Uh, I feel all HBSS very badly. CSQ. Great, I have not worried about current stuff. Again, what I'm going to do. In left, okay. Call -1, call +1. This case class. What is the problem? I'm looking the same, bro.
Oh, bro. Shit. Mm,
Huh. See, this is also not working. Please don't tell me this is going to work. It will hurt my mind. Oh my God. How? What answer did you pen while you the popular for answer dot open not dot data? How the hell bro? कैसे? Okay, this is going in this, what's happened in that thing, and this happened in this. Why happened in this section? It is already opened it. Oh my God, bro! I never expected this to be this much easy in a. I have no words for this. Okay, this is. I'm done for today. Okay, let's call this day and good night, guys. Bye bye.